I welcome you all again. Today we have a very interesting topic, and this topic is very important for the UPSC examination and some other examination also. There are n numbers of questions. Those comes as a descriptive examination, descriptive form, and as in also as a multiple choice exam questions also. So this topic is very important, and let's discuss about the thrust and reverse faults. So thrust faults and reverse faults are the dip slip fault where we can get the up dip movement against a fault plane. Here this is the fault plane and this block is moving upward direction. This is the hanging wall block and this one is the foot wall block. So here hanging wall block moving the up dip direction. So reverse faults are the up dip movement. Up dip movement means they show the displacement against the dip direction of the fault plane. So the hanging wall block has moved up relatively to the foot wall block. So reverse faults have more than 45-degree angle. We can see if the angle of the fault plane is more than 45 degree, that is known as reverse fault, and if the angle is less than 45 degree, it will come into the thrust category. Okay, so the basically difference is based on the angle. And yes, one more thing, reverse fold always put the older rock over the younger rock, as we can see in this block diagram also. A reverse fold put the older rock over the younger rock. This is the first expression when the fault was originated. After some time, what happened? Weathering and erosional activity was activated and eroded the uplifted portion, because we everybody knows that when you we uplifted portion always very tends to the weathering activity. So this is the picture of the reverse fault after some time when erosional activity and weathering activity weathered the uplifted portion. Okay, so and just one more thing, this reverse fault and thrust put the thrusted seat over the older rock. As let's take an example from the Himalayan region. In Himalayan region, what happened along the MCT? Suppose that this is MCT. So along the MCT, all the higher Himalayan crystalline rocks comes over the lesser Himalayan crystalline rock in the form of napes and clippes. Just let's take an example. Almora nape, Kathmandu nape. All these nape come from higher Himalaya and right now staying over the lesser Himalayan rock through MCT and STDS. So all the napes and clippes are the form of the large recumbent thrust seeds. These are the examples in the Himalaya. So okay, thrust fault characteristically in place older rock on the top of younger rock. We have discussed this thing. Okay, the horizontal separation across the thrust fault can be variable depending on the attitude of the layer before faulting. Yes, this is very important topic. Okay, then if plutonic or higher grade metamorphic rock overlie low grade or unmetamorphosed sedimentary rock, the normal structure sequence is inverted, suggesting the thrusting has occurred. So this is very important factor about the recognition of the reverse fault or thrust fault. Okay, then we have one more classification of the Anderson classification that is about the reverse fault. So Anderson classification says that if the sigma 3, this is the minimum stress direction, if is vertical, reverse fault take place, and sigma 2 and sigma 1 should be horizontal. So this geometry we can represent with the help of stereographic projection also. Sigma 3 should be at the center, means sigma 3 is vertical. Always remember this sigma 1, 2, 3 representing the principal stress direction, then intermediate stress direction, and this is the minimum. So these are not the poles. Always remember. So examiner can ask such type of questions also. He can give the sigma 1, sigma 2 and sigma 3 relationship and can ask the identify the right type of fault. So always remember that in the reverse type of fault, sigma 3 always at the vertical angle, and vertical angle is at the center. This is the equal area Smith stereographic projection. Okay, then thrust duplexes. So thrust duplexes is basically what happen in thrust duplexes. Duplexes Stress duplex is a system of imbrication, as we can see in this sketch diagram. Stress duplex is a system of imbricate thrust fault that branch off from a floor thrust. This is the floor thrust, branch of floor thrust below and a curve upward to the join a roof thrust. This is roof thrust. So in the duplex system we have two types of fold thrust. One is floor thrust that separate to the undeformed rock or less deformed rock to the deformed rock, and one is the roof thrust. Okay, this is the demarcation of at the top of the in the form of roof thrusting. So thereby forming a stack of horses, as we can see the stack of horses. The geometry of these trusses resemble to the horse's neck, and you can see the neck of the horse. So these structure also known as the horses of the reverse fold. So duplex is necessarily contained within the stratigraphic section, like on imbricate fan. However, a duplex can develop along a frontal ramps also, so on which the main thrust rise towards the foreland. Okay, so duplexes exist a variety of forms depending on the amount of displacement. Okay, as we can see here, depending on the displacement, a variety of displacement, and individual horses also, as we can see individual horses also. So hinterland form a zone of roughly constant thickness between the roof and the floor thrust with greater displacement. They form an antiformal, as we can see here. They are forming the antiformal stress with still larger displacement, and you can see the larger displacement from here to here. There is a larger displacement. They dip predominantly towards the foreland, again defining a zone of roughly constant thickness between the roof and the floor thrust. Okay, so overall, thrust from the horses as well as the duplexes also, and the geometry and the displacement along the geometry is different. Okay, one more thing I want to add here, the geometry of the reverse fold. So the geometry of the reverse fold is deep thrust fold generally are listric fold and curved toward the shallower. When we move towards the shallower, they will become a listric. This example is not good. Here we can see this one is the listric one, means listric is the curved one. Well, okay, normal fold and reverse fold always in the form of listric one. Okay, then reverse fold, the features associated with the fold surface. Reverse fold always show the positive structures, as we can see here. This is a positive flower structure. This one is moving up, this one is moving up, this one is moving up. So whole structure is moving up, and this is the positive structure due to the reverse folding. So this is an example of the thrust from the Himalaya. So first example is all the napes, those are situated over the lesser Himalaya in the form of crystalline rock. These are the thrust example. They are thrusted from the higher Himalaya through MCT and STDS during 20 plus minus 3 MA years, million years. Okay, so Almora Nape is the largest nape situated in the northwest Himalaya. Another one example is Kathmandu Nape. Then Klipe, Ascot Klipe, Chakori Klipe, and Lansdowne Klipe. All these three clippes basically situated in Kumaon and Garhwal Himalaya. Then Himalayan frontal thrust (HFT), as we know, Himalayan frontal thrust is very famous. Then main boundary thrust (MBT), and the age of the MBT is 10 plus minus 2 million year. Then main central thrust. The age of the main central thrust is 20 plus minus 3 million years. MCT and STD both are coaxial fold. Okay. Then how we can recognize the thrust in the field? Previously, I have made one presentation basically on the normal fold, where one observer asked a question, why this breccia existing in the hanging wall of the normal fold. So I am giving the answer here. That actually breccia always occurred in the hanging wall in the normal fold and always occurred in the foot wall of the reverse fold due to the extensional regime. In geosciences, extension is the negative force and compression is the positive force. So compression exceed the strength of the rock. So if we have a high competitive or a high means strong rock, so there is no chance to get the fractures. So that's why in normal fault breccia always occurred in the hanging wall. This is the reason, okay, because there is a extension. So extension always promote the weak zone or fractures, because that is the weak zone. And compression in geoscience always means increase the strength of the rock. That's why we are not getting the breccia and all the cataclasites and all the fragmented material in the footwall side in the normal fault, and in the case of reverse fault in the hanging wall side. This is the reason. So let's come to the reverse fault. So in reverse fault in hanging wall structure, and this is the compressional structure, and we get reverse fault, sub reverse faults also, and relation so up dip movement. Then lacking of intrusion will get in the hanging wall direction because there is a compression. If there is a compression, then there is there no can means there is no weak plane and there is no intrusion can take place. Okay. Then grade of metamorphism obviously. Then subsidiary reverse fault we can get regularly in the hanging wall movement. Then footwall structure, we can say this footwall structure is always extensional. Okay, this one is reverse here. In reverse fault, footwall structures always show the extension and hanging wall structure always show the compression. I am correcting here, don't go for the written format. I am correcting by words that hanging wall structure always show the compression and footwall structure always show the extension. This one is written due to because there is so many exam where we have to compare the, or we have to correct means match the correct one sequence. Okay, so in the footwall structure we'll get lineation, so dip down movement means along the dip movement we will get in the footwall structure. Then boudin structure, because there is a extension, so boudins always occur in the extension. Veins or intrusion always occurred in the footwall, and breccia also. So I think you will get the question of that you will get the answer of that question where you ask why we are getting the breccia in the extensional regime. Okay, so this is the correct answer. Then one more criteria, we can get the breakage in the topography. As we can see here, this is the depression and this is the uplifted region, and here we have a breakage in the topography. This is high elevated region and this is low elevated region. This photograph is taken from the Missouri region, and this is the main boundary thrust, and this higher elevated region is the lesser Himalaya, and this is MBT, main boundary thrust, and this low lying area is the Dehradun Valley. Okay, so I hope you will enjoy this video. So thank you. I will come again very soon with a new video. Thank you very much.